Hare Krishna. Hope you're doing well. Let's get started with this question on computing the best critical region for the given hypothesis testing setup, where we have the underlying distribution as the normal distribution. Okay, now we first note the hypothesis and use the Neyman Pearson lemma to observe the best critical region with respect to the likelihood ratio. The likelihood ratio is the ratio of the PDF under the alternate hypothesis divided by the PDF under the null hypothesis, which is essentially this. The square root 2 pi sigma gets cancelled because both are having the same normal random variable distribution, same variance. And this likelihood ratio can be simplified into this form, and the important thing to notice is the likelihood ratio would be greater than equal to k if and only if this quantity, the sum of the two random variables, is greater than equal to some other value appropriately, because the likelihood ratio is an increasing function of x1 plus x2. So this is how we can infer that the critical region is going to rely on these two and will be of this form. Now, for this implicit one-sided test, we would have now x1 plus x2, if you think about it, is going to follow normal to theta and variance 2 under the null hypothesis theta is equal to 2. So, sorry, 1. So, we have under null hypothesis this following this distribution, which means x1 plus x2 centered by the mean and scaled by its variance must follow the standard normal distribution. And this is where the given cutoff point comes in. It's essentially x1 plus x2 minus 2 scaled by square root 2 greater than equal to z alpha, which would give the critical region, and mean x1 plus x2 greater than equal to 2 plus z alpha square root 2. So we have c as this quantity. So this becomes 2 plus the appropriate thing. This is 2 plus this, and this would be essentially not 3.96, 4.32. Hence, this is the right option. That was it. Take care. Hare Krishna.